Good evening everyone. So today I am going to present our IoT project that focuses on capturing and visualizing the sound intensity using ESP32 microscope. So we are presenting by Durga Prasad and Rachna. So let's start our project and choosing the ESP32 as our microcontroller. The ESP32 is well suited for IoT project because it has a built-in Wi-Fi and Bluetooth, which eliminates the need of the additional network module. It also a powerful enough to handle sensors, input, processing and network communication all in one compact device. So to measure the environment sound, we connect our sound sensor to ESP32. This sensor detects variation in sound, pressure level and sound output analog digit, which is ESP32 reads using its analog to the digital converter. So this gives us a numerical value that represents the intensity of the sound in the environment at a given moment. So once we had the hardware setup, we write the control logic using the Arduino IDE. So Arduino IDE is a simple and widely used platform that supports the ESP32 board, and it is made easy to write, upload and debug our code. So in our script, we included code and to read the analog signals from the sound sensor, process the data and prepare its transmission. So the next step is connecting ESP32 to the Wi-Fi. So this allows our device to send data over the internet. After successfully connecting to the local Wi-Fi network, it configured to the ESP32 to send the sound data to MQTT broker. So MQTT broker is a lightweight messaging protocol that ideal for IoT because it uses low bandwidth and provides a reliable way to send messages from devices to a server or a cloud system. So from the MTTQ broker, we use a tool called Telegraph, which is an agent that collects the process and forward the metrics. So we configured Telegraph to subscribe to the MQTT topic wherever ESP32 was published data.
And here comes the visualization. For visualization, we have used the platforms such as Grafana, which is the most popular open source for analytics and visualization. Here we have used the Grafana with the integration of the InfluxDB, which is the database for the time series to design the analytical process with time-stamped data. Here we have collected the data with the over the time period of sound system from the environment, and here we can see the God chart which represents the sound variation over the time period and also fluctuations. And next coming to the another chart. Here we can see the bar chart where the sound fluctuations we can see the high and low, and we can see that 208 is the most highest frequency which is collected, and there is the lowest frequency, and the data is fluctuating the over the time period. Here we can see the optimization of these time series with the metrics of data. This built on the data and we can see the one more graph such as histogram where it shows the where we have collected the data, and we can see the 800 is the most highest recorded data in the value of 1000 to 1600. We can see the all the values here down in our and here coming to our project, the sound was sorted and connected to the Grafana to the InfluxDB to visualize this. Through this we have visualizing these three charts, and the first graph, the second graph, third graph, we can see the time variations and also the fluctuations of the sound. and the integration of these two provide us an efficient pipeline and the data collection to store the real-time visualization. This is not only the powerful tool for only for our project, but it is used most widely even in the IoT industries, healthcare, and the smart city developments.